move on to chapter 2 now. Chapter 2 is called Functions and Graphs, and one of the main ideas from this chapter is going to be using something called the modulus function. There's also domain and range, which is an important idea. Composite functions and inverse functions, that's really the same as GCSE. And then at the end, we're going to bring everything together. Okay? Links with transformations of graphs here. So what is the modulus function? Well, the modulus function we show with these two sort of gates here, either side, two vertical lines. And what they mean is they mean to take the positive value, the absolute value. So, for example, if you say, what's the modulus of 6? The answer is just 6, because the answer is positive already, so it doesn't change it. But if you were to talk about the modulus of a negative number, well, we say that's just a positive version of that. Okay? So, the modulus function returns positive values, or I suppose you could return zeros as well, but it can't return negative values, not unless you do something after the modulus. So a couple of quick examples we're going to do here. We've got some function, and this function here is the modulus of everything that's inside. So what we're going to do is we're going to do this 2x minus 3 function, and then we're going to make sure that the answer is positive. If it's positive already, nothing will change. If it's negative, we'll just effectively take away the minus sign. So for example, f of 5, this notation means that you take all the x's and you replace them with 5s. So it looks like this. So what happens? Well, 10 minus 3, so the absolute value of 7 plus 1. So when we do that, because it's positive already, it's just going to stay positive. So it's just 7 plus 1, so it's 8. So it doesn't change anything there at all. Okay? F of minus 2. So f of minus 2, we can just do the same as before and just change the substitution. So minus 2, minus 3. So that's going to be minus 4 minus 3, so it's minus 7. And then again, we're going to take the modulus of this one here, plus 1. So what's the modulus? Well, it's actually going to be 7, so 7 plus 1. So we end up with the same answer. This is an interesting result because if you sort of look at what we're starting here, 2x, not x squared or x cubed or anything, 2x, you might recognize this is linear. And normally when something's linear, when you take an x, it gives you a y value. And you can think of it backwards as well. For any y, there's normally only one x. However, that doesn't seem to be the case here because two different x values can give you the same y value. And why is this? Well, if we're looking ahead a little bit, what I've done here is I've graphed 2x minus 3 plus 1. It's a bit sort of silly doing minus 3 plus 1, but the idea is you can see without the modulus signs, it would look sort of like a normal straight line graph. Minus 3 plus 1 simplifies to minus 2. That's why there's a y-intercept there. And it's got this positive, slightly steep gradient. Okay, we'll look at where this comes from in a moment, but if I'm to compare with the modulus, you'll see here that on the right-hand side it seems to share the same space, but on the left-hand side it's very, very different. And you'll notice it seems to be positive up here and not negative, and that's connected to the modulus idea that we just talked about. What were those values that we just had? So we had 5 and minus 2. So if we check 5 is, if we zoom out a little bit, 5 is up here, which gives you 8, and minus 2 also gives you 8. So that's what's happening here. Okay, more than one x value can lead to the same y value. So what we're going to do next is we're going to have a bit more of a look at where the shape of this comes from.